Hey folks, welcome to this session. Today we're going to be diving into building production quality Gen AI applications. My name is Niall Turbitt. I'm a data scientist on our professional services team. So what that means is that I work with customers to build and deploy production Gen AI applications on Databricks. We also have Eric and Nikhil with me. Eric is product manager. Nikhil is on our engineering team as well. And what we're going to be working through today then is really just focusing on building production quality Gen AI applications. So we'll first be laying out why is it hard to build high quality Gen AI applications. We'll be focusing for the majority of this on RAG applications and primarily RAG over unstructured data. We'll then be laying out what are the steps that you need in order to iterate towards high quality Gen AI applications. And then what does it mean to go from proof of concept to production with your RAG application? Eric is then going to walk us through a demo just to show you what this all looks like practically on Databricks then. Just to set the scene, what this talk is not. So we're not going to be doing a whole intro to retrieval augmented generation covering what is RAG, when to use RAG. There's some great talks out there. For an intro to RAG, Ian is going to be giving a talk later today at 5:10. We're also going to be stressing the importance of evals, and we're going to be speaking a lot about evaluation-driven development. We're not going to be covering, however, a whole deep dive on evaluation, the theory of evals, how you go about creating evaluation sets, LLM judges, metrics. For that, again, there's also a great talk that Alkis and Mike will be given later on today at 2:20. So go to those sessions for all of that. So let's start. What are the challenges of building high-quality RAG? So just to state it plainly, creating high-quality, accurate RAG is hard. Why is this the case? So firstly, it's difficult to measure and evaluate accuracy. If you think about a RAG application, it can be inherently difficult to figure out what is the right answer. And in cases where you can define what a right answer is, it's often difficult to collect that in a very efficient, in a very scalable way. On that point in particular, then, it's difficult to collect enough feedback. So where you can collect the right answers, it's often very manual and labor-intensive to do so. It's difficult to improve accuracy and reduce hallucinations. So in particular, as we'll see, these systems, there's a lot of moving pieces. It's hard to know, well, what do I change in order to affect output quality? How do I go about improving accuracy? How do I address hallucinations? And then lastly, what we want to do is enforce guardrails all along that entire system. We want to make sure that the system is not producing inappropriate, harmful outputs. So we heard a lot this morning about compound AI systems, and RAG is just one flavor of compound AI systems. So more generally, creating high-quality, accurate systems is hard. And essentially, a compound AI system is really any system in which you have that generative AI component. And this could be anything from function calling, that Casey was showing us earlier, through to agents, where there's an aspect of planning to it as well, and what we'll be focusing on today, which is RAG. So quality is a systems problem. And just to show you why this is the case, let's actually deep dive a little bit into what a RAG application looks like. So one example of a compound AI system. So first, what we're seeing here is a fairly high-level overview of what a RAG application could look like. And obviously, there are various ways that you could go about implementing a RAG application, but just for the purposes of example, let's assume this is something like a customer service chatbot, and you have a set of PDF documents that contain this proprietary internal documents. What we want to do, and how we would go about building a RAG application, is that you would have these kind of foundational pieces of your data pipeline, which is going to take that those internal documents, and it's going to process it and index it so that you can make it searchable. So this would be creating a vector index, storing those documents in there to make it searchable. We would then have the kind of heart of the application, the RAG chain itself. And what this is going to do is take user requests, given a user request, going to retrieve supporting data, feed that to an LLM, and you're going to generate your output. So let's kind of pull back the layers a little bit more. If we look into the data pipeline itself, and again, this is just one fairly straightforward way that you could go about thinking about building a RAG application. You're going to have these various components in your data pipeline. First, taking the raw data itself, and you're going to need to parse in our case, raw documents. Think of this as something like, I have a PDF document, and I want to extract the text from that. For parsing alone, you can think about all the different options that are out there. There are a ton of different parsing libraries, such as unstructured or even kind of actually paid services to do so. Other steps along the way is going to be extracting metadata. So you have to make decisions around, well, should I extract section headers? Should I also extract page numbers within my PDF documents? You're then going to be taking those documents, chunking them, embedding them. And again, decisions that you're going to need to make there is, how do I go about chunking those documents? What chunk sizes should I use? What chunk overlaps should I use? What embedding model should I use? If you go to Hugging Face, you're going to be presented with 100 different options of embedding model that you should potentially use. That then gets synced to our vector index. Let's now zoom in then on the RAG chain itself. And one example of how you could go about implementing a RAG chain looks something like this, where you take the user query, you first have an understanding component where it's taking a user query and deciding what is the intent of that query. You then have the retrieval component of it, so retrieving the most pertinent information given that user query, taking that support data, feeding it into a prompt template, and that augmented prompt is then fed into your LLM, generated output from your LLM, and oftentimes there's a post-processing element to this. All along the way, you have guardrails. And again, at each level there, within each of these components, you can think about there are various different decisions you could make around how you go about implementing this. How do I implement my retriever? How many chunks should I go and fetch? In terms of my prompt template, you can go down a whole rabbit hole of prompt engineering. On the LLM piece itself, what LLM should you use? How prompts fed to different LLMs might not work the same way. So as you can see, many different levers that you could think about pulling in order to improve quality. However, if we want to go about improving quality, really what we need is a target to aim at. And oftentimes when you're building these RAG applications, and I've been there myself, is that you can enter into this POC doom loop where you're iterating on these different components and settings blindly with no objective way of measuring improvement. Anyone who has built a RAG application knows this all too well. You've implemented your retriever in one way, you're retrieving maybe the 10 most relevant chunks, you feed it to your prompt template, does quite well, you slightly adjust the template, you slightly adjust the number of chunks, all of a sudden, quality completely changes. You then tinker with a different chunking strategy, you see the quality is uplifted again, but then you change something else and all of a sudden quality deviates. How do you do this? How do you make changes in a systematic way so that you can track how those changes impact quality? And what we see as the foundation in order to be able to do this is evaluation-driven development. And you might be looking at this and saying, okay, evaluation-driven development, that's absolutely nothing new. We've always been doing evaluation-driven development in ML. And yep, absolutely right. However, with evaluation-driven development, which we define as consisting of metrics in evaluation, metrics being one way of how we go about defining quality, evaluation being the actual process of objectively measuring metrics. While in the traditional ML sense, we have always done this, within a systems-based view of the world, it does require a slight shift in how we approach things. So just to give you a bit of an example, think of a classic ML application where you have, say for example, an XGBoost model that you're training to predict customer demand. You would take that model, you have your historic data, you're training on the historic data, you're evaluating it against that historic data. So you have a ground truth. What is my ground truth? Customer demand at that historic point in time. So metrics are evaluating the inputs and outputs of that single model component. And given that single component, overall metrics are equivalent to component metrics. However, with this systems-based view of the world, component metrics are going to be needed in order to evaluate inputs and outputs of each of those components. So whenever we're saying components here, what we're referring to is that retriever component, the generation component. Furthermore, because you have all of these different components interacting with each other, we need compound metrics in order to evaluate how those multiple components play with each other. Another step up is that we need overall metrics to measure the system more holistically, to evaluate the overall input and output of that system. On the evaluation side of things then, in the traditional ML view of the world, output is deterministically right or wrong. So coming back to our customer demand example, we have a ground truth of what historic demand was, and we can train against that and measure against it. So deterministic metrics such as RMSE, precision, recall, accuracy, they work in these scenarios. However, in this systems-based view of the world, while output can be right or wrong, there can be many right answers. So if you take something like, I have a transcript and I want to summarize an audio transcript, there are many different ways in which you could correctly summarize that transcript. Also, some answers are more right than others. So what we need is, firstly, we need human feedback for these systems, and we need an efficient way of being able to do that. In addition to that, we need model judged metrics in order to scale that and do so in a programmatic way. And so a model judged metric might be something like correctness or groundedness. So given the information that we're retrieving, given a user query, and we're providing that retrieved data to the LLM, is the LLM grounded in its response? Is it listening essentially to the retrieved data that you have provided it? So given this view of the world, this evaluation-driven development, what does it look like going from POC to production with Gen AI applications? And so let's sketch out what the development workflow would look like. So as with any use case, you're going to be gathering your requirements initially. Following that, you're going to be quickly building and iterating and deploying an initial POC. At this stage, more often than not, you're not going to have something tangible to kind of aim against and measure against. It's a manual process to collect feedback and initially measure a baseline. Following that, you're going to move into a phase of improving quality. So I've got a baseline to at least work off. I'm now going to improve the quality of the system as a whole, moving through deployment, monitoring, and having this cycle where we're trying to constantly improve the quality of the system. What we need to underpin all of this, though, is an evaluation set. And an evaluation set in the sense that we're talking about is going to be a data set of input user prompts, or user queries, and gold standard outputs that we expect the system. Additionally as well, what we ideally need is for that input query, what should be the retrieved data that we fetch given that user query? So what are the chunks, what are the documents that should be retrieved given that user query? So given that we have an evaluation set, how do we go about the big part in the middle? How do we actually go about improving quality? So given that we now have a target to aim for, and we have a way of collecting and building that evaluation set, how do you know which lever to pull? So we can think about quality across two different lenses. So the first being retrieval quality. So are we retrieving the most relevant information and providing that to the LLM? It's going to be inherently difficult for the model to generate high quality output if we're not feeding it and providing it the correct data. So this could be something like missing important information in terms of the support data that we're providing the LLM, or on the other side of the coin as well, it could be providing too much information. There's all of this distracting information and irrelevant information that we're providing to the model. On the other side of things, we also have generation quality. So this is thinking about, given the retrieved information that we're providing the model, plus the original query, is the output high quality? And per generation quality can manifest itself across many different ways, but you can think of this as hallucinations, inconsistent output, failure to address the actual input query. So given that we have a way of framing this. We've got retrieval quality, we have generation quality. We saw previously there are all of these different levers that you could go about pulling, all of these different components. Just in your data pipeline, you can go down a complete rabbit hole of what parser should I use? How should I use metadata? Should I use metadata as metadata columns? Or should I actually put it into the chunks? How do I go about chunking? What embedding model should I use? Then on the other side of things, the RAG chain itself, what LLM should I use? If I have a certain prompt for one LLM, will it work with another? There's a ton of different choices that you need to make. So really what we want, what we need is a way to make changes in a systematic way to improve quality. And what we're introducing to solve this are two pieces. It's the Mosaic AI Agent Framework and the Mosaic AI Agent Evaluation. Also, what we're going to be sharing at the end of this as well is a whole generative AI cookbook that we have put together to collapse a lot of our learnings, best practices, plus the thing that I think you'll probably be most excited about is code to back a lot of this. So with that, I'm going to pass over to Eric, who's going to walk through what this all looks like on Databricks itself.
Awesome. Thanks, Niall. So we talked through a lot of the challenges around RAG. We talked through the challenges around systems. What I'm going to show you now is what we announced earlier in the keynote, the two products that Niall's mentioned. We'll go through a hands-on demo. And what we'll do here is actually I'm going to build a bot that we built and use internally. So we have a lot of folks in the field who, I guess, interact with many of you and have lots of questions that come in from their customers. And so internally in our Slack, we have a RAG bot that looks over our documentation and a variety of other proprietary information to allow them to quickly get answers to the questions that our customers ask. So what I'll do is I am going to go ahead, and the first thing that I'm going to do is I will build and deploy a proof of concept. And so a challenge that Niall's mentioned was, hey, like, how do I actually measure ground truth? How do I measure the quality? And so what we're able to do, so I've actually deployed this already. We'll go through the details of building the POC in the beginning session at 5 p.m. today. But what I did was I went ahead and I deployed this out, and I'm going to go ahead and get the review app. And so what the review app is, it's an application that you can distribute to anyone in your company, even if they don't have a Databricks account. And I'm going to ask it, what is Lakehouse monitoring? So what this enables you to do is hand your proof of concept application to your business stakeholders who have knowledge and expertise in the topic area. What these folks can do is they can then come and give you feedback on these responses. Maybe this was a bad response. It wasn't helpful. They can also take a look at what were the documents that came back with each of the RAG responses. So this allows them to give you feedback and explain to you how your app isn't working in the proof of concept. This data, it then flows through into your Lakehouse inside a Delta table where you can access it. And so what I'm going to do is we're going to go ahead and just look at some of these traces here. So these are sitting inside a Delta table. I can click, for example, on what is Lakehouse monitoring. I can see a detailed trace view that shows exactly what happened inside the application. This allows me to, first of all, debug what's happening. Also is attached to the user feedback that was generated. So we'll walk through in depth in the advanced evaluation session at 2 p.m. today, the process of going from this user feedback to an evaluation set. But for today's purposes, I actually already built this evaluation set off of that feedback. And so, as Niall's mentioned, we have some questions that users are likely to ask us, what the ground truth responses are, as well as information about the document that's relevant here. So what I'm going to do next is, if we go back to our workflow, we've built our evaluation set. Now, I need to measure the baseline quality for my proof of concept. So what I'm going to do here, this is normally a pretty arduous process. You have to figure out which metrics do I use, what are the right ones, how do they work, do I trust my LLM, what's the judge look like? There's a lot of complexity that's here. And in an agent evaluation, we've taken all this complexity and exposed it in one simple command for you. So all you need to do is, I'm going to grab the MLflow run of the proof of concept. So I have my model logged in there. And I'm going to go ahead and with one line of code, I'm going to say, here's my evaluation set. Here's the model. and then model type Databricks agent. What this is gonna do is it's gonna go ahead and run the LLM judge-based assessments on this. It's gonna load it into my MLflow environment. And so I can see here, this is the proof of concept model. So I've got a chain. I can see some of the different parameters. I was using 4,000 characters, for example, an open source embedding model. And these metrics are now loaded. So let me take a look at these in the MLflow UI. And so as Niall mentioned earlier, the metrics that we look at, we're gonna look at some generation quality metrics. We're gonna look at some retrieval quality metrics. And so let's first go ahead and look at the generation quality. So here, overall assessment in terms of the answer correctness, 65%. So it's not too great. The next metric we'll look at is the groundedness. So based on the retrieved information, is the LLM hallucinating or is it grounded to this information? And so in this case, it's actually almost 100%. So the LLM is responding exactly based on what's coming back from the retriever. So it's kind of weird. We're at 65% correctness. We're very grounded. So let's take a look at our retrieval. And what we can see here is that the retrieval quality is actually a little bit lower than we'd like, 85%. And so look through this stuff offline, and loosely my hypothesis right now is that what's happening is there's so much information coming back from the retriever that the LLM is getting confused and not able to find the correct information in there, right? Because I have okay retrieval quality, low answer correctness, but yet I'm fully grounded and not hallucinating. So in order to figure this out, I actually need to dig in. So from here, I can switch over into the interface that allows us to look at each single response in the evaluation set. And so you can see up here, these LLM judged assessments are all sitting here, along with the information, the response, the model's ground truth, and the chunks that came back from the retriever. So this is a really useful interface to actually inspect and understand what's happening, which is a critical part of a quality-driven development workflow. So I'll pick this one example. And this question here, how do I use PyODBC to connect to a Databricks SQL warehouse? So the ground truth, it's, there's some code that's required in order to do this. And what's actually happening in this response, again, thinking about my hypothesis, maybe the models are getting confused. The model here, it's just summarizing, it's essentially explaining to me what the retrieved context is. This is a guide. It starts by explaining. And so if we come down and we actually take a look at what's being retrieved, let's take a look down here. It's actually got the right article. But if we look into this chunk, what we can see is the first set, there's kind of a bunch of relatively irrelevant information. This is actually the table of contents in the document itself. It's a lot of information. You just keep scrolling through this chunk, you can see eventually that the right answer is actually here. But there's so much additional information in this chunk that the LLM's getting confused. And so what I need to do now is I need to go fix my chunking strategy. Now, for anyone who's fixed the chunking strategy, this is not just like grab a cup of coffee, program for 20 minutes, and I've got an awesome pipeline on the other side. It's actually a pretty hard piece of effort. So what I'm gonna do, before I actually go do that, I'm gonna just get some quantitative metrics to try to look at my hypothesis. And so I was saying earlier, hey, I think the problem is that I'm not retrieving the right information and the model's getting confused. So I looked at retrieval precision between when it got it correct and when it didn't get it right. And there's a pretty big delta here. So this gives me enough confidence to actually go and try and build my new data pipeline. So in order to build the data pipeline, first thing I need to do, this is the document that I was showing you in the chunking interface. This is what it looks like in real life. And so if you look here, all the things on the left that were coming, those are not necessary. And so if you inspect this page, what you can actually see is that there's some structure to it. And so you can look, the article body is just one section of the HTML, and these headers up here at the top give me some additional information. Let me see if I can highlight those. So now this is kind of giving me information, and what I did was I went ahead and I updated the data pipeline. And so what we're looking at here, this is the configuration of the pipeline from our cookbook. And so I changed out the parser from the default parser to a custom-built parser and chunker. In interest of time, I won't go too deep into what these are, but essentially I use Beautiful Soup, an open source library, to go ahead and parse that structure of the document and fix it. So I ran the pipeline, just ran on Spark, and what I got out the other side was I logged this all into MLflow, so I can kind of track and be aware of what's happening in the life cycle. And I've got these delta tables. So if we look at this one, this is the chunk documents. We can take a look at a few of these. And just to quickly inspect, I can see the chunks, they look a lot cleaner. There's no kind of additional information in there. I'll zoom in for folks. It's clean. The problem though, just because I invested all that time does not necessarily mean that my RAG is gonna work. So I need to go back and I need to evaluate it again. So this is super easy. I'm gonna come back up here. I built it. What I've done here, sorry, I can't zoom, is I went ahead and I loaded the original configuration for my baseline model in MLflow. The data pipeline spit out a new configuration for me to use, and I'm just looking here at the differences. So I'm just gonna switch out the vector index from my old one to my new one, and I've got a nice little tag so I can track it over time. So super easy here. I'm gonna log my model to MLflow. So I'm gonna log that chain back there. The key thing here is I'm passing this updated configuration. So we've expanded MLflow's capability. You can parameterize models now, which make it really easy to hold the code constant and add in this new data pipeline. You'll see this same command from before, calling it again, running the LLM judge on it overall. And let's take a look at the metrics that came out. So I will turn on this one, and let's look overall. So quality, overall correctness has gone way up, which is great. Let's actually look at the retrieval quality. Looks like I've increased there as well. So this is, it's easy now. I have a quantitative metrics that I can check my changes against. Now, that being said, metrics tell you one part of the story. You always need to go look at your data. So I'll come back here into the same UI as before, and I've got the same example. Let's see if I can get that to load. Just refresh this. So let's look at this example. And so you remember the ground truth from before. It looks like what's happening, the model's getting it definitely right this time. If I come down and I look at my chunks, I can see the first chunk that's coming back, actually, instead of being all the way at the bottom of that chunk, the relevant information is at the top. So it's a lot easier task now for my model to go through and do. So again, I've looked at one, offline I inspected a lot more and I was seeing a similar pattern, but I like metrics. So I went ahead and I just double checked. I took the records from before, the ones that had a low retrieval precision, and then I compared it to the ones afterwards. Same records, A to B. This is nice because the agent evaluation, it puts all the data into a data frame for you. So you have this available, it's there, it's in your notebook. And I got about a 10-point increase in retrieval precision. So I'm not just hallucinating that one example worked better. I actually have some metrics. And so this makes conversations with my boss or with my business stakeholders easier. I have metrics to show. So we've got that. I think if we go back and look through this really quickly, we'll see that everything is not perfect. So we still definitely have some examples to work through. In interest of time, I'm not going to work through all of these, but in the natural state of things, you'll iterate, you'll continue this process to improve the quality of your RAG application. But one thing I did notice, cost and latency, this was important to us in this use case. And so if I look here, I'm actually able to, in the same thing, out of the output of agent evaluation, look at the cost and latency. And so from the red bar, which is the bottom bar, original chain, to the top bar, which is the new one, I actually drastically increased or decreased the latency from 10 seconds to 5 seconds. I decreased the cost, so the number of tokens that I'm using. But what I had noticed earlier, and I didn't show you guys this in the interest of time, but essentially I noticed that a lot of when I was looking at all the chunks, the ones that I needed were actually within the first 1, 2, or 3 chunks a lot of the time. And so what I said was, hey, maybe I can optimize the cost or latency here a bit. So I went back and I updated my chain's configuration again. I changed it from k equals 5 to k equals 3. I reran evaluation. Then what we'll look at here, I'll add this run in, and overall, I dropped correctness by a percentage or 2. So I'm slightly less accurate, but I'm a little bit faster, and I'm almost 2/3 cheaper. So this now at this point, you have the data in hand to go have that conversation with your business stakeholder. Do we want that extra point of accuracy? It's gonna cost us. Or are we okay trading off a few points of accuracy, but we'll save almost half of our use case? So now you're armed with this data to make these decisions with your business stakeholders. And in interest of time, because we're running a little bit behind on time, I'm just gonna skip to what I did at the end here was I deployed it to a REST API. I used the model serving product. And then I also put it back into the review app. And you can actually share instructions with your reviewers. So you could send this back to your business stakeholders. And I wrote a little note to them. I actually computed the metrics. So look, we went from 65 to 95. We increased the speed by 50%. And we dropped cost by 75%. It's kind of a nice little token of appreciation for the help from all the folks who kind of went through this. So with that, that's agent evaluation and an agent framework. The goal here is, one, if we think about our overall approach, we want to give you as developers the fastest experience to iterate. You're going to have hundreds of ideas. You need to try them all fast. Two, you need to try those ideas fast and get human feedback on them. With that human feedback and with this fast dev loop, it's really important that you can actually reliably measure quality. So this is what we're aiming for with the agent evaluation and the agent framework. It's fast, it's reliable, and it's easy to get feedback from your humans. So with that, all of this is in public preview. So there's a demo notebook available. The cookbook is up there. We've got some QR codes on screen. So take a picture if you want to try this out. If you're a Databricks customer already, it's in your workspace. It's ready to go. Really excited to get y'all's feedback on this. And we have about 7 minutes left. So we've been thinking a lot. I think we've made building high quality a lot easier with these capabilities. But Nikhil, Nikhil, if you can come up on stage with me, we wanted to show you a bit more of a forward-looking vision on how we're going to take the data intelligence that we have now that your apps are built on top of Databricks, and how we can use that to make your lives as developers even easier. So, Nikhil.
Awesome. All right, thank you, Eric. So, as Eric mentioned, my name is Nikhil. I'm going to be talking about a forward-looking vision, so a product we have not built yet. That's going to talk about how we can continuously improve our AI applications over time. So I want to ground this with a few key points that need to happen for this to be successful. So the first is that we need to understand what's happening in production. What are the types of questions users are actually asking our bot, and do we have holes in the model's understanding of the world? The second is that we want to make it really easy to automate root cause detection. When the model fails, is it failing because it's hallucinating? Is it failing because it's not getting the right context? There's a lot of ways it can fail, but we want to be able to give you breadcrumbs to point to where we can fix it. Number three, this is very important. We want to make sure that humans are in the loop of this process, and more importantly, business users are in the loop. Humans should be making decisions about what the model can and can't talk about, what it should know about, and what it should refuse. This is very important to making a high-quality AI application. And then finally, we want to use AI as much as we possibly can to fix all the grunt work of data, config, and code, and make that as easy as possible to empower the human being as much as possible, right? Okay, so that's the motivation. And so this beautiful image will try to paint the picture of this product for you. And so because at Databricks, we are a data intelligence platform, and we have visibility over your data, so your vector store, your search index, your eval set, and your logs, your inference tables, we can marry these all together under a single umbrella that we'll call maybe something like app intelligence, right? So we have a view over the entire app, and we can improve your data, your eval sets based on what users are actually asking in production and have a really virtuous cycle. Okay, so I'm gonna switch over to a demo now. And again, this is not launched or anything, this is just a prototype. Let's see if I can zoom in. Okay, so in this view, what we're looking at, I'll just stand here, is a marriage of the vector store, the evals, and the logs into a single UI. And this is your app, okay? And what we've done is we've broken these three down by topic, where each topic is automatically generated by our AI. And those topics are, what are the users asking about, right? So completely automatically generated. And so we can see things like Databricks environment versions, right? These are users asking about environment flags. And so if you look at that row, we can see that our vector store, our search index, actually has pretty good coverage for this topic. So we're probably in good shape there. But if you look here, our evals are actually not doing well. We're actually getting 33%. So you might want to focus on fixing this. And then if we look at the logs column, we actually do have production logs. 9% of them contain this topic, and so we need to pay attention to this. So if we actually focus on that last column, we actually will run the judges that we do for evals over the logs and give you breadcrumbs of how we can fix things, right? So immediately we can see that there's non-relevant chunks and the responses aren't grounded for this topic. So this is a place that we might want to focus on. Okay, so now I also, my manager came to me and said, hey, we just launched this agent evaluation and we want to know, are we doing well on this? And are users asking about it? So what we can do is we can go and create a custom topic here, which is this button. And I'm going to type agent evaluation here for the topic. And I'm going to type a description. And that description is very important because it's going to tell our AI how to find retroactively documents related to this description. And so we're going to type, a framework for improving the quality of AI applications. And we're going to click create. So what this will do is now retroactively go through your data, your evals, and your logs. Oh, you can't see this, sorry. Nice. Thank you. Okay, so what we'll see now is there's a new row where we have a tag that says we have no data in our vector store. We have no evals for this topic, so we're definitely not going to be doing well. And users are talking about this, and quite a bit in the last 7 days. So we've actually seen a spike over the last 7 days. And moreover, users are giving us negative feedback. It's kind of hard to see here, but there's a negative tag, and I can't scroll down. But there's a negative tag here, and we have non-relevant chunks, okay? So this is an area we're going to focus on. And I'm sorry that you can't scroll here, but that's okay. And so what we're going to do is we're going to click on this 2%. And just like that UI that Eric showed you before, we're looking at the logs now. So these are the 3 logs where a user has asked this question: how do I evaluate the quality of a RAG application? And we've responded with evaluating the quality of a red, amber, green application typically involves assessing a few key factors. So we all know that that's not what RAG stands for. So this is clearly hallucinating. And if we scroll down and look at the chunks, we are actually giving chunks related to red, amber, green reporting, completely unrelated to what we're talking about here. So we're doing badly. So we want to focus on these few to fix. If we quickly go through the other ones, what is agent evaluation? These are also hallucinating something about quality management systems, the unrelated chunks here. This is not doing well. And the third one, same thing. Okay, so let's try to fix these 3 queries and improve our application. And so the way we're going to do that is we're going to actually add these 3 to our replay queue. And so by clicking this plus replay, what we're essentially doing is adding it to a local queue of a few queries we just want to focus on for now that we're going to fix over time. Okay, so once we do that, we're going to go up to our replay queue, and we have these few working queries that we're going to go ahead and improve. And so in this case, we know that we just are missing docs for it, right? We know that we don't have data in our vector store, which were those breadcrumbs from before. So we're gonna go ahead and upload new data about these documents. So when I click this upload button, we get this familiar UI where we can upload files, but there's a new button, Discover from UC, which will actually, using the Databricks Data Intelligence Platform, search through all of your Unity Catalog public documents and find things actually related to those queries, completely automatically. And so we found these few HTML files. I'm gonna click upload, but normally you would send these for another human being to review. That's the right process. This is the wrong process, but this is a demo. So we're gonna click upload, and this is immediately gonna upload those to your vector store, chunk them, do all the fancy stuff we were talking about before. Once we come back, we can now click this replay button. And with this new chain, with this new data in our vector store, we can just ask, what does the model think for these 3 queries now? And side-by-side diff them. And so again, we have this red, amber, green stuff going on the left. On the right, we can see that we're talking about evaluating the quality of a RAG application now much, much better using the agent evaluation suite. If we quickly poke through the other 2, these are much better responses. We can actually see that the judges are telling us these are pretty good too. So we're in a much better state now, and we've improved the system. Now, I wanna make sure we never fail on this again, and so we can now permanently add these to evals by clicking this Add to Eval button. Again, we might wanna have a human being look at this, so we can request that. Again, for now, adding to evals directly. So I'll just add these 3 to the eval set, and now these are permanently tracked over time, so I won't regress on these in the future. So I'll stop the demo here. Let's see if I can go back here. So you can see how that really makes a quite interesting data flywheel where we continuously monitor and improve these things over time. And so the last thing I will end with is actually a Slido where you can scan this QR code and vote on which pieces of this are the most interesting for you. Where should we prioritize these, right? Because I told you this is not built yet. We want to build this in the future. So these are the sort of 4 areas we're thinking. If you could vote on these, that would be awesome. And with that, I will end it. Thank you.